So in this video, we're going to be talking about properties of quadratic functions when the graph is of the form in standard form. So our f of x equals ax squared plus bx plus c. So our first thing, which way does the graph open and how do you know? Well, quadratic equations can open two ways. They can either open up or they can open down. And how we know this is what the a value is. That's right. So our a value is going to tell us. So if a is positive, then our graph is going to open up. But if a is negative, then our graph opens down. So what is the axis of symmetry? Remember that our axis of symmetry is the x value of our vertex, and it's also the line that goes through the vertex that creates that symmetry, right? So it's the x value, but in this case, because we don't have vertex form, we need an equation, and that equation is going to be negative b over 2 times a, and that will give us the x value of our vertex, and it will give us our axis of symmetry. Remember that sometimes we use AOS for short, for axis of symmetry. All right, so our vertex is either the highest point of our graph or the lowest point of our graph. It just depends on if our graph is opening up or if our graph is opening down. Now, because we don't have our vertex form, we're going to have to use our equation. So for our vertex, the x value is actually just our axis of symmetry, right? Just our axis of symmetry. But the y value is going to be the answer when we plug our axis of symmetry into our function. So what that means is if my axis of symmetry was, let's say, the number 2, then I would need to plug that into my equation and see what answer I got out. And whatever answer I got would go right here, and then that would be my vertex. Let's move on and talk a little bit more about the vertex. Is our vertex a maximum or a minimum? And how do you know which one, right? So a maximum value is when our graph is opening down, because it puts our point at the highest level, right? We have a minimum when our graph is opening up, because it puts our vertex at the lowest level. So we can tell if we have a maximum or a minimum all based on our a value, because that tells us if our graph opens up or if our graph opens down. So remember, if our graph opens up, then our a is positive, and that's going to give us a minimum. But if a is negative, then that's going to give us a maximum. So is the graph going to be wide or is it going to be narrow? And how do you know? Well, this also has to do with our a value. So our graph will be wide when the absolute value of our a value is smaller than the number 1. So it's going to be between 0 and 1 if it's the absolute value. So like a fraction, like 1/2 or 7/9, smaller than 1. And it will be narrow when the absolute value of our a value is larger than 1. So this could be like the number 2 or 4 or 3/2, because remember 3/2 is 1.5, and that's bigger than the number 1. So that's how we can tell if our graph is wide or narrow. So where exactly is the y-intercept of this graph? And this one's actually pretty easy. It's just the c value. That's it, just the c value. And we can say that the y-intercept is c, or we can even write it as a point, 0, comma, c. And so these are the properties of a quadratic graph when you're given the graph in standard form. It helps you know a little bit more about what you might be graphing or some other characteristics and properties that the graph has without necessarily having to graph it. It also helps you graph it when that time comes as well.